All right. Any questions so far? Everyone's good? Everyone has these notes. Part one. Okay, here we go. So on part one, we're talking about residual and what does residuals mean? So if you look on here, we have a graph. And this graph represents a scatter plot. So the scatter plot are the diamonds. So everyone sees the diamonds. The diamonds are scatter plot, our original points. So all these points are plotted. The blue dots are regression points. So the regression points are the points that we get from plugging into our regression model that we've been finding, right? Okay. So the space, the line in between that space, that's called our residual. Okay. The difference from our actual to our predicted or our expected, that's called our residual. Got it? Our residual tells us how accurate our regression model is for the data that we have. All right. So on your line, it says residual means what? On your line, you're writing residual means actual y minus your expected y. So on the line on your paper, you're writing actual y minus expected y. Where it says residual means. I did. Everyone found it? Everyone's good? Okay. So when we're talking about the residual, we're going to analyze whether it's positive or negative. And we also want to minimize it. That's our goal there, okay? Is to minimize the residual. Thank you. Okay. All right. So on the next part, you have blanks to fill in. It says on one way to determine how well a linear model best fits the data set is by squaring the residuals and examine the sum of the squared values. Okay. By examining the residuals and squaring the sum of those values. All right. Why do you think we would square the residuals? Anyone? Safe space to guess. What would be a reason to square a number in general? To find the root, that would be the square root. Yes. Square root is undoing it, but yes, you're on the right track of a word, so yes. Okay, we'll run with that one. So the reason why we square it is the main reason is so that all values are positive. So this is the long one. So squaring the residuals is going to ensure that all of our values are positive. Okay, you can paraphrase that, you can write it however you want. But this helps us so that when we are finding the sum, nothing gets canceled out. Okay, because if everything is positive, then there's no chance of having opposite values and canceling things out. Getting worse. Okay, in geometry, geometrically, what did it mean when you were squaring something? In geometry, not that long ago, when you were squaring something or had squared units, what had you been doing? Multiplying by itself to find the way. If I'm squaring something or if I had squared units in geometry, what was that? What were you referring to? If you had squared units. Close, but not that one. Not volume, but area. Yeah. Squared units is area. Anytime you have squared units, that means you found the area of something, right? Volume, that was your cubic units. Okay. If you had cube units, that means you found the volume. If you had squared units, that means you found the area of something. Ring bells a little bit there. Okay. So geometrically, what you are doing is when we are squaring something, we are finding the area. Oh, that's a horrible underline. It won't let me erase my horrible highlighting, but use her. I'm going. Okay, we would be finding the area. Okay, so when we are finding the area, we're finding the areas of our residual length, and that's why we're squaring. The goal here is to have the smallest. The smaller the area means that the error has been minimized. Okay, so we're going to try to say that together. The smaller the area means the error has been minimized. Ready? The smaller the error has been minimized. Okay? The smaller the area has been minimized. Error has been minimized. Such a weird two words to say at the same time. Area and error. Area and error. Okay? So you want the smallest line, right? Your residual needs to be small. And if our residual is small, that means my area is also going to be small, correct? And that's what we want, because we want our actual and our expected to be as close as possible to each other. That means that my linear equation is a good representation of what I'm doing. Does that make sense? So during your do now today, you had a discussion that asked you about 3 ladies, right? And what we're going to be doing with those 3 ladies is deciding who was actually correct mathematically. And we're going to go through the process of figuring out their residual and their area squared, the sum of their area squared, because that's going to let us know who has the best one. The person with the smallest sum is the most accurate. Does that make sense? Okay. In life, you want the least amount of errors as possible. Okay. The least amount. And that's how you know you're on the right track. Okay. So, I noticed some of y'all are writing still. Hopefully you're not trying to write everything. I tried to highlight what was really important and you can paraphrase from there, but I'm going to go. And if you need to come back, we can come back later, but we're not writing all of it. All right. So we're going to analyze Stella, Jasmine, and Bronny, because Stella and Jasmine and Bronny are really cool kids and they went on a road trip. And when they made it to their destination and they went in and checked into their hotel, they're like, hey guys, I wonder, like, what was the linear regression of our travel? And, you know, they had a contest to see who could like make the best prediction of their linear regression model. So we're going to analyze to see was Stella, Jasmine, or Bronny correct? Okay. We're going to analyze them using 3 different methods. Okay. So not only are we going to find the regression, the residual, but we're going to learn 3 different methods of doing it. Okay. The methods that we're going to learn are going to go from tedious to not so tedious to, oh, this is really easy. Okay. So we're going to start off with the most tedious so that you can appreciate the really easy. Does that make sense? All right. So let's start our journey. In the drawer somewhere over there. All right, so the steps that we're going to follow are listed on your paper. So when you open your paper, your little booklet, you'll see all 3 of the equations that were on your discussion post. You see all 3 of the equations that were on your discussion post? Okay, you'll see all 3 of their equations, and then you're going to see the steps that we're going to follow. The first person that we're going to verify and check is going to be Stella. So we're going to be using Stella's information and then analyzing it. The way that we're following Stella's information is by following the steps below. So the steps below tell us that we're going to graph the equation in y equals. We're going to change our window to fit the given information, then graph. We're going to find the expected y values by either, we have 2 options. So we've already learned how to find the value on a table, on a graph, by pressing second, trace, and 1. Today, we're going to learn another way of finding multiple values using the TI-84. And that process is by going to second window and changing it to our auto to ask for our independent. Okay. So we're going to learn a second method. Either method is perfectly fine. I'm just going to show you that you have options. Okay. I'm really big on giving you options because I feel like that helps you take ownership of your learning. You choose which method works best for you. Okay. Then we're going to find the difference by pressing second mode and subtracting. Remember I told you, you just got to be able to subtract today, right? And then from there, we're going to find the residual square by squaring the difference values. We're going to be toggling back and forth between 4 and 5 for each row of data. Does that make sense? We're going to find the difference. We're going to square it. We're going to find the difference. We're going to square it. We're going to find the difference. We're going to square it. Is that cool? All right. Are we ready to dive in? So if you get lost on any of the steps, they are on your paper. I encourage you to keep it open and follow along because the steps will not be on the board with me. All right. So here is my first equation with Stella. I'm going to open up Sylvie. And you can either open up your digital calculator or use your handheld that I encouraged you to pick up when we came in. Okay, so up first, it said the first thing we're going to do is graph our equation, which is right here, into y equals. So I'm going to go to y equals, and I'm going to graph 1 400 times x plus 3 4600. Okay, the second thing it said was to adjust my window to guarantee I can see my values. By adjusting my windows, I'm going to analyze what my x values are, and I'm going to analyze what my y values are. My x values, lo siento. So my x values are right here, 30, 62, all the way up to 185. So I'm going to make sure that my window is set from 0 to 200. And that's going to ensure that I can see every value in my given domain. Does that make sense? Okay. Your X scale right here is just how many tick marks do you want to see? I don't want to see 200 tick marks. So I'm going to set mine to 10. No, I'm going to set it to what they're counting by on the photo. And on the photo, we're counting by 25. So I'm going to put it at 25. Because that's what, not 125, just 25. Do you guys see what I mean when I say look at the graph? So looking at, move over, at Stella's graph, you can see she goes from 0 to 200, and she's counting by 25. So you see what I mean? And on the y-axis, she's going from 0 to 200, and she's counting by 25s. And that is what I'm telling my calculator to do. So x is set in. On the y, I'm going to go from 0 to 200, and I'm going to count by 25. Okay, so now when I hit graph, I should have a replica of what Stella has on her paper. Yes? Okay, so that's what the first thing told us to do for step 1 and step 2. Are we good with step 1 and step 2? Okay, step 3 is where we're finding our values at. So step 3 says to find your expected y values. To find your expected y values, we're going to plug in our values here are 30, 62, 85, 125. And that's where we're going to get our expected y values. Okay. You have two options. Option number 1 is the way that we learned on Tuesday. You can press second trace, click value, type in what you want, and you're golden. So I typed in 30, and it says it's at 34 6600. Okay. That's option number 1 of filling in those values. Again, I press second trace, and I type 1, just like it says on your notes, second trace 1, and I typed in the value. Okay. The next option of doing it is by doing it all at once without having to press second trace multiple times. To do that, we have to change our table settings. So we press second window, like it says on your notes, and we're going to go down to where it says independent IDP NT, and we're going to switch it from auto to ask. So again, how did I get here? I press second window, following exactly the notes on the paper. I went down to independent and switched from auto to ask. Once there, we now can go look at our table. When we go to our table, we press second graph, and our table is blank. Oh no. Okay, the reason why it's blank is because you said to ask me, what do I want in here? So I'm going to type in all the values that I want in my table. I want 30. I want 62. I want 85. I want 124. I want 151. And I want 185. Ta-da! And I have all the values plugged in from that table. Okay. So when you have multiple values, I think turning your independent on to ask is more efficient. If you don't, then, whatever, floats your boat, go for it. All right. So we have 67 and 9400s. We have 91 and 8600s. We have 132 and 42 hundredths. We have 160, is it 160 and a half? And we have 195 and 86. Do a little group table check and ask everyone, did they find these table values? Check all your peers. I see someone's calculator. What's on there? I'm very tired too. I've been up to 3 o'clock grading, so no sense to be given. Alert, pay attention. Okay. All right. Are we good? Yeah. All right. So now we're going to find our residual. So our residual is the difference between your actual and your expected. So we're subtracting. Ooh, it's a weird equal sign. So we're going to subtract to find our residual. Okay. To find our residual squared, we're going to take whatever we get here and we're going to square it. Does that make sense? Okay. To get to your calculator page, remember you press second mode and that takes you to your calculator page. Okay. So to get from the table, which is where I was at, to get to my calculator page, I press second mode and now I'm going to do the process. So I'm going to do 30 minus 34.66 and then I'm going to square its value. So exhibit A, 30 minus 34.66 and I get negative 4.66. Okay. To grab that answer, I'm going to put parentheses, arrow up, enter, and then I'm going to square it. And that's what goes in the next box. So these are my two boxes. So for the residual, I got negative 4.66. And for its residual squared, I got 21.72. Is that okay if I write 72? Do you think you can do that? Okay. So I'm going to pause on me talking and I'm going to give you a chance to fill in the other 5. Got it? Again, if you don't. Okay. So for 62 and x equals 62, what was the residual? Negative what? Negative 5.94? Negative 5? Negative 2? Did you get 2? Yeah. Because it should have been 65 minus 67. Okay. What's the square of that? 8 and 64 hundredths. Okay. Next. We have 10 and what? 14. And so the square. Okay. Next. And what was our square? And then, and what was the square? 20 point what? And then, and 34 point. Okay. So, when we look here, what we should come to the conclusion is that when our expected value is over, the residual is going to be negative. So if your expected value is over your actual, that's going to be a negative residual, okay? If your expected value is under, then obviously it's going to be positive. So it's going to be opposite of what you think, okay? Next is finding the sum. Did anyone go ahead and find the sum of our numbers? So if we add all of our squares together, what do we get as our sum? 193. That's not a 3. 193 point what? You got 60? 6.3. Okay, there we go. Okay, so that is Stella's score right now. So that is the score to beat for the other two if they want to be correct. Okay, does that make sense? So this is her score of her predicted equation. How do we feel? It wasn't bad. I gave you fair warning about the process. I did. Okay. All right. Now we're going to learn the second way of doing it using your TI-84. Okay. The second way is the calculator does all of the math. All right. The calculator does all of the math. The problem is you guys tend to freak out on remembering steps and you want someone to constantly tell you the steps. And that can't be the case, right? So these are the steps that we're going to be following. I'm not going to read them all out to you because it's just easier to do these steps, but you're going to follow along. So the steps are here, the problem's on the back. So I'm going to put the problem up for you so that you can keep the steps in front of you. Does that make sense? Okay. Because you don't need the table right away. Trust the process. Okay. So here we are. We're now verifying if Jasmine was correct or better than Stella. Okay. To determine that, we're going to use another method of using the TI-84 to find the residual. So here's my calculator. All right. I'm going to go ahead and reset my calculator. So I'm press second plus 712. I like to do that, especially when I'm about to enter into stat edit, because the first step says that you're going to go to stat and you're going to go to edit, which we've used before, correct? In stat edit, you're going to put in your given X's and Y's. So for this problem, this is our X, this is our Y. So this is going to be our L1 and this is going to be our L2. So we're going to put in those values. 30, 62, 85, 124, 151, 1. Oh, thank you. I didn't press enter hard enough. Okay, and then we're gonna come over here and we have 30. Oh my goodness. Donna Jones. There we go. 185 and back over. And now we're at 65. I need to say them out loud. I don't know why I'm not. 102, 130. It works better for my brain to hear it and see it. 190. All right. So everyone has their L1 and L2 in. Yes? Okay. We are going to put our expected Y values in L3. What do you mean we? I mean the calculator. Okay. The calculator is going to do it for us. In order for the calculator to do it for us, we're going to arrow over and up. You have to be on the L3 in order for this to work. Okay. If you're not on L3, it will not work. All right. Basically, we're going to tell the calculator, I want you to find it for me. Okay. And in order for it to find it for me, we have to tell it what values it's using. It's going to use our X values into this formula for us. But for right now, our X values are in what column? L1. So we need to write this out so that it's 1.09 times L1 minus 2.81. So we are going to, your L1, 2, 3, 4, they're all on top of their corresponding numbers. To get to them, we press second. So we're going to start off by putting in our slope, 1 and 900ths, times our L1. And our L1, we press second, 1, to get it to say L1. Minus 2.81. So we're telling the calculator to take all of these values and plug it in for X. Does that make sense? And then we press enter, and guess what it does? It plugs it in for us. Okay, so I will do it again. I came over to the L3, and in L3, I'm going to clear it out so you can see. So we started off here. We came over here, and our L3 is going to represent our expected Y's. Okay, L3 is our expected y's. In order to get our expected y's, that means that we need to take all of these values and plug them into what Jasmine thinks is the working function, right? So when we come over here, I'm going to type 1.09 times second L1 minus 2.81. And I press enter and the calculator does it for me. Okay, still with me? Okay, next is our L4. Your L4 is your residual. It's your difference. Okay, so your difference is when we subtract our actual minus our y, correct? So in this case, we need to subtract our L2 minus our L3, and that's going to help us create our L4. So we're going to go over to L4 because we want L4 to be L2 minus L3. So we're going to press second 2 minus second 3 so that we can tell the calculator to make L4 our L2 minus our L3. And then we press enter. And it does it for us. And then you write them out. I mean, you can do it in a minute. I'm just making sure we're good. But now I have everything. Are you still with me? All right, last one is our L5. Your L5 is your residual squared. Your residual squared comes from your L4, right? Comes from here. So that means we need to square our L4. So we're going to tell the calculator to find our L5 to square our L4. So I'm going to go over and up because I want to change all of L5, not just one, all of it. And we're going to put in parentheses, I need you to take all of L4 and I need you to square it for me. Please and thank you. And I press enter, and what does it do? It does it for me. Did it do it for you? Isn't that nice? Okay. So the thing is, you have to remember that you're inputting them in the L and not in the boxes. Okay. It has to be put where the L is because you want it to change every single thing. All right. Now, the other good thing is if you're not strong at rounding, you also can go to mode and say, hey, I need you to round my values to the nearest 2 decimal places for me. And when you go back to your stat edit, it'll round all of your values to the 2 decimal places for you. Okay. You go to mode and you'll switch from float to whatever amount of decimal places you may need. So in this case, our boxes are tiny, so we're going to keep it at 2, right? You just go back to where you were, your stat and your edit. And it'll round all the values. Now, does it also add unnecessary zeros? Yes, that's because I said I need to see up to 2 decimal places, okay? And now, do I have everything I need to fill into my table? Yeah. How do we feel? Good. Okay. I'll give y'all a moment to write down the values, and then we're going to talk about how to let the calculator find your sum, or you could just add up all the values. But if you have a bunch, it kind of gets annoying, right? Like, that's a lot of typing. If you feel confident, you can work ahead to find the sum. That's step 5. So if you feel pretty confident, you can go ahead and follow step 5. Otherwise, just wait and we'll do it together. Go to mode and go to float and switch it to 2 or 3, whatever you're trying to round it to.
Thank you.
Mm-hmm. Did they what? Camilla came and got it. You're talking about the poster? Yeah, Camilla came and got it. It's gonna be a little lazy. I don't feel like typing. Sorry. There's no point. See how it's magically coming in there for you? It's crazy. Technology blows your mind. Close enough. Close enough. You get the gist. I don't know what time it's left. I just be teaching. All right. Are we ready to find the sum? All right. So to find our sum of this lovely table that you now have, right? We're going to go back to our calculator page. So we press second mode. Second mode. Take me there. Not just mode, but second. And we're going to press second stat, just like it says in your notes. And you're going to arrow over to math. And you're going to look for sum. See the word sum? You're going to press 5. And we want the sum of our L5, right? Our last column. So we're going to press second 5 and say, please add this up for us. And there it is. And thank you very much, Sylvie, for assisting me in my life. I really appreciate it, girl. Okay. So then our total is 241. 241.97. So right now, who has the better score? Stella, because remember, we want the least amount of error, right? And so Stella is at 193, and poor Jasmine is at 241. Womp, womp, womp. Did anyone put Jasmine as their answer for the discussion? Nobody? Nobody? Okay, okay. So the odds were against her anyway. All right. All right. How do we feel? Pretty good? Okay, tomorrow when you come in, you're going to do the practice without me using your notes. So tomorrow, be prepared. You choose your poison, okay? Do you want to do it, where you get the satisfaction of plugging things in and subtracting and squaring yourself? Or do you want to practice remembering how to make the calculator do it for you, okay? So this is going to be your do now when you come in tomorrow. Got it? Yes.